Hey guys, hope you're well. So this lesson is all about ionization energy. We're going to be talking about what ionization energy. I'm going to explain quite a lot in this lesson. It's going to be awesome because, trust me, I have a nice way of explaining it that will allow you to really have a good idea of what ionization energy is. We're also going to be talking about periodicity with ionization energy. So we'll look at certain patterns on the periodic table when it comes to ionization energy. Okay, so you and I, right now, we are going to go on a mission. Our goal is to go and rob an atom. We're going to go rob an atom, and you know what we're going to try steal from that atom? We're going to try steal one of its electrons. Okay, let's quickly draw an atom. So we know the basics of an atom. We know that it has a nucleus, and in the nucleus you've got lots of positive charges called protons. And then you've got these other ones which are neutrons. They don't have any charge. Then on the outside, you've got electrons, and they come in these energy levels, okay? So let's just go maybe make 2 energy levels, and let's go scatter some negative electrons. Okay, let's put some there. Let's put one there, there, and there. Right, now guys, our goal is that we are going to try to steal one of these electrons, okay? Now, the electron that you steal is always going to be the first electron that you steal will always be one of the valence electrons, okay? It will always be one of the valence electrons. And now, what is a valence electron? A valence electron is an electron in the outer energy level. So all of these 3, those are valence electrons. Okay, now guys, you got to be a little bit quiet because we don't want... Okay, Kevin, that's lame, dude. These guys are not grade 1. Sorry, guys. You're normal. You're grade 10s. Okay, so we're going to... Bro, homie, what up, what up? We're going to steal some electrons. I'm trying to be more cool now. So what we're going to do, guys, is we need to... Let's say we're going to go for this one, okay? Now, you and I, we are going to try to take this electron and we're going to try to take it away. We're going to try to remove it from this atom. The problem is, though, is that you see this electron, it's negative, okay? And this area over here is very, very positive. And so, unfortunately, there is an attractive force over here. There is an attractive force. They are attracting each other because opposite charged things attract. Okay, so we are going to have to try to pull this electron away. So we're going to have to try to pull this electron away. But the problem is that there's some type of force over here, some type of electron and proton force they're attracting each other. So what are we going to need? We're going to need energy. We need energy. Energy will allow us to pull this electron away from this atom. Now that energy that we need is called ionization energy. How cool is that? So right now, I'm sure some of you have just realized for the first time what ionization energy actually is. So ionization energy is the energy needed to remove an electron. Kevin, is it really this easy, bro? Yep. It's energy needed to remove an electron from an atom. Okay? But then just remember to say in the gas phase. For some reason, that's the way scientists have defined it. In the gas, your teacher might say gaseous phase. Okay? Just remember that last little part. It's pretty random. But anyways, it's the energy needed to remove an electron from an atom. You can remember it like that. If we are able to remove that electron, then it won't be part of the atom anymore. And it will now be floating around over here, for example. Okay, so just remember that for now, guys. Now we're going to start looking at the periodic table, and we're going to look at how the ionization energy changes as you go across the period, and we're also going to see what happens when you go down the group on a periodic table. That's the important part. So for now, just remember that ionization energy is the energy that is needed to remove an electron, okay? And we might even be able to move more than one electron, but we're going to get to that in this lesson, okay? We still got quite a bit we're going to go through, but right now I hope you just understand the basics. Okay, so now we're going to start looking at the ionization energy periodicity, so the way that it changes as we go across a period. And this gets quite interesting. I'm quite excited for you guys to see this. So what I want us to do is we need to remember one of our previous lessons where we spoke about radius. I hope you understand radius and how the atom sizes change as we go across a period. That's important that you understand that, okay? If you remember that lesson, we learned that in this period over here, all of these atoms are in row 2. Okay, so what that means on a atomic level is that they all have a nucleus. So here you would have lithium, for example. Here you would have beryllium, and here you would have boron, for example, if I had to do the first 3. Okay, they all have 2 energy levels around them because they are all in period 2. Okay, so this is something we've spoken about in previous lessons. But what we spoke about in that lesson was that if we look at lithium, it has 3 protons. Okay, so it's got 3 protons. So you can just say, let's rather put the lithium over here. So we just say plus 3. Beryllium had 4 protons, and then boron has 5 protons. So what we said in one of those lessons was that because, and then remember on the outside here, we've got electrons. There's always electrons on the outside. Now, electrons are negative, so they are attracted to anything positive because opposites attract. So what we said was that this nucleus is more powerful because it's got 5 positives. So it would be able to pull electrons more closer to itself because it attracts them more strongly. So what we said from that was that boron is going to have the smaller radius compared to beryllium, and beryllium would have a smaller radius compared to lithium. And so what we said was that as you go from left to right in a periodic table, the radius decreases. So lithium might be like that, beryllium like that, boron a little bit smaller, carbon smaller, nitrogen a bit smaller, oxygen, fluorine. And then we don't really look at the noble gases in periodicity. We don't look at that too much. So that's the trends that we have observed in previous lessons. So how does that affect ionization energy? Well, that's what we're going to look at right now. So here I've got the first 4 atoms in period number 2 from the periodic table, and I've shown that the radius, as we've learned before, the radius is becoming smaller. Okay, so remember, in the middle we have a nucleus which has protons. Okay, so I'm just going to put positive over there. We know that they've got protons. Okay, and then on the outside we've got electrons. I haven't shown all of the energy levels. I'm just going to show, actually I'll just show 1 electron for each of them. I'm not showing all of the energy levels. Okay, and those are the electrons that I've just drawn. And so those are negative. Right, so what we've learned is that, well, what we know is that this is positive and negative. So there is a attractive force between them. Okay, so let's just show that there's some type of attraction force over there. So let's say attraction force. Now we know that ionization energy is the energy that we need to try take this electron away. Now can you see that with lithium, this distance is quite large? Can you see that distance is quite large if you compare it with this distance and this distance and this distance? So what happens is that it is going to be more easy to be able to take this electron away compared with, for example, this one over here. Why? Because the closer that these two can get to each other, the stronger that attraction force will be. And that means it will be more difficult for us to remove the electron. So we would need more energy. So which one is going to be the easiest to remove? This one will be the easiest to remove. Then it will be this one. Then it will be this one. And then this one will be the most difficult. Okay? And that is because, once again, when this distance, think about two magnets. If you put two magnets very close together, they attract each other. But when they're further apart, it's not such a strong attraction force. So we can make a little summary now. And we can say something like, as atomic, or let's say in the same period, atomic radius decreases from left to right. Okay, we know this already. We can then say that this decreases the distance between the outer electrons and the nucleus. Okay, and remember the nucleus is the part in the middle. The decreased distance causes, or let's say the decreased distance, or let's rather say as the distance decreases, as this distance decreases, the strength of the attraction force or attractive force between electron and nucleus increases. Okay, so you understand that, right? So as that attractive force between the electron and the nucleus increases, it is going to become more difficult for us to be able to remove the electron. So that means the ionization energy, which is the energy that you need, is going to go up. So we can then say ionization energy will increase. Okay, so as we go from left to right in the periodic table, the ionization is going to increase. There are some exceptions to that rule, though, as you go from left to right. Some of the ionization energies do decrease a little bit as you're going from left to right, but that's not going to be the topic of this lesson, okay? In this lesson, I'm just giving you the basic trend that we know. I just want to give you little bits at a time. So what we're going to look at now is we're going to look at what happens to the ionization energy as you go down a group. What we're going to look at now is what happens to ionization energy when you go down a group. So we're going to start with lithium, and then we're going to go down to Na. Now, can you remember, if you had to draw the atom of sodium, which is Na, it would obviously have its nucleus in the middle, but now Na is in energy level number 3, whereas lithium was in energy level number 2. So lithium has 2 energy levels like that, whereas Na is going to have 3. So around the nucleus, it's going to have 1, 2, 3 energy levels. And then this part in the middle is the nucleus. And so what we learned, and what we can see here, is that the radius is becoming larger. Remember, the radius is the distance from the middle to the outside. So what we have learned about in previous lessons was that as you go down a group, as you go down a group, you add energy levels. You add energy levels. This increases the radius. This increases the radius. Okay, so as you go down a group, you add energy levels. This increases the radius. So that's something we've learned in a previous lesson. Okay. So, and let's just say here that this is Na. Now, if you had to go and draw potassium, it would be even larger. It would have 4 energy levels around it. So that's huge. Look how big that one is. Okay? And so that would be potassium. Now, we need to now think about the ionization energy and which electron will be easier to remove and which electron will be more difficult to remove. So remember that over on the outside, we're going to have some valence electrons, okay? And then on this one, we're also going to have some valence electrons. Now, it's all about the distance. Well, there's a few other factors that I'm going to mention as well, but it's mostly, one of the big factors is the distance from the nucleus. So look at that distance, and then look at that distance, and then look at that distance. So what we can see is that in potassium, it is a really large distance. Remember, the longer the distance, the weaker this force will become. It's like taking two magnets. If you put the magnets close together, they are very attracted. If they're further apart, they're not as attracted. So the distance is a very important factor. So that's one thing that we're going to talk about, but there's a few other little things we need to talk about as well when we're adding energy levels like this. We must remember that we've got electrons on the outer energy levels, okay? We've got electrons there. So for example, like sodium, we could put some of them like that, for example, okay? But then we also have electrons that are in energy levels that are on the inside. These are called core electrons or inner electrons. Okay, so you get something like that. Then with potassium, and then with lithium, of course, we have that as well. So lithium would look something like that. And then with potassium, it would go something like this over here. And then it's also going to have on this energy level and on this energy level. Okay, so, and those are all electrons. So what happens is that these electrons that are on the inside, what they almost do is they decrease the effect of this nucleus on these electrons on the outside. It's almost like these electrons are getting in the way. We call this the shield effect. Okay? And that's something we're also going to talk about when we make our summary in a few minutes. That's the shield effect from all of the electrons that are on the inside. So these electrons here are going to shield, or what they're going to do is they're going to almost block the force from this nucleus. So there will be less force exerted on these electrons because these ones are almost getting in the way. They are blocking the force a little bit. Okay? And then another thing I want to talk about is that these electrons on the inside, they're still electrons, they're still negative. So what would these negative electrons do to these electrons over here? Would they attract them or repel? They would repel, which means that it tries to push these electrons off. Okay, so that's another thing I want to talk about, the repulsion effect. So now I want you to think about this carefully. Is it going to be easier for us to try and remove this electron over here, or this electron over here, or this electron over here? Let's just put one of them over there. You've got to try to think about which one's going to be easier to remove. Well, if we first think about the distance, it's going to be easier to remove this one because the distance is larger, and so this force of attraction is much weaker, or it's much less, so it'll be easier for us to come to this electron and be like, hey, electron, you coming with us? And then this electron's going to be like, no, but I'm holding on to my proton. And then we're going to be like, yeah, but you're not holding on that strongly because this distance is quite far. So this proton hardly knows you, bro. And then the electron's like, fine, I'll come with you guys. And then you just take this electron away. So it's easier to take this electron away because this distance is so far. Okay, so we've looked at that. I'm still going to make a nice summary for you guys, but I'm just going through these. Now let's look at the shielding effect. The shielding effect is the way that these electrons on the inside block the nucleus force from reaching the electron. It blocks it a little bit, okay? It shields it. It's a shield. You know, like when people in the olden days used to fight with like swords and shields? Well, it's a shield. It blocks. So with this one over here, look at how many layers of shields there are. You see there's multiple layers of shielding, and so this electron, this poor electron over here, is hardly able to experience the force of the nucleus because these electrons are getting in the way. They're blocking that force, whereas this electron is hardly being blocked at all, and so all of this force is able to reach this electron. So once again, this electron here is going to be so easy to remove because whenever we try to take this electron, it says, hey, no, but I'm being attracted by my proton. And then we can just be like, yeah, but it's hardly affecting you because of all of these inside electrons. So you easy to take off. Come with us, dude. You can just come with us. And then this electron's like, okay, fine, let's go, and I'll come with you guys. Whereas this electron over here is like, no, I'm not coming with you guys. I am strongly attracted to this proton. Thank you very much. I am not leaving at all. So it's going to be easier for us to take this one. Then it will be, the next easiest would be this one. And then the most difficult would be this one. Okay, so we looked at that. The next one is the repulsion due to the electrons on the inside. Now, this electron over here is being bullied a little bit. You know by who? It's by these electrons. These electrons are also negatively charged, and this electron's also negatively charged. All electrons are negative. So these electrons and these electrons, they keep telling this electron, go away. We don't want you to be here. We don't want you to be our friend. Because negative electrons repel each other. They push each other away. So there really isn't much trying to keep this electron over here. So I don't know about you, but this electron's going to be really easy to take away, whereas this electron is going to be the most difficult to take away. Okay? So the ionization energy, which is the energy that you need to take an electron away, will be the lowest for this one. This one will be medium, and this one will be the highest. So this one you need more energy. More energy is needed. And then this one has the least amount of energy is needed, because this one's the lowest. Okay? But now we're going to put all of that into a summary. Hope that makes sense so far. So, as you go down a periodic table group, you add energy levels to the atom. This increases the distance of the outer electrons to the nucleus. This increased distance decreases the force of attraction between the nucleus and electrons. Therefore, I'm going to do distance by itself, and then I'm going to do the shielding effect, and then I'm going to do repulsion. Okay, so we have some nice summaries for you guys. So therefore, ionization energy. Remember, ionization energy is the energy that you need to take the electron away, so the ionization energy will decrease. So remember that. As you go down a periodic table, as you go down the group, the ionization energy is going to become less. What that means is it's going to become easier to remove an electron. Okay, now we're going to talk about the shielding effect. So we spoke about distance. Now I'm going to summarize the shielding effect for you. So you might need to pause if you're still writing anything down, but I'm going to go to the shielding effect now. Okay, so I'm going to leave the first part. As you go down a periodic table group, you add energy levels, so that stays the same. Now for the shielding effect, what happens is that the valence electrons, or the outer electrons, let's just call them outer electrons, will not be able to experience the full attractive force of the nucleus, as the force will be shielded or blocked by layers of inner electrons. Okay, that's the shielding effect. It's when these electrons over here and these electrons here and here, they get in the way and they cause they block or they shield the effect of this nucleus trying to attract this electron on the outside. Okay, now we're just going to talk about the repulsion effect. Okay, so for the repulsion effect, I'm going to keep the first sentence, and then we're going to say the outer electrons will experience more repulsive forces from the electrons in the inner energy levels. Or from the inner electrons, let's just say that. From the inner electrons. We can say more energy levels mean more inner electrons. There will be more inner electrons the more energy levels you have. For example, here we have 3 energy levels. So the inner electrons are all of these. Okay, those are, oh no, not these ones. Whereas in this example, the inner electrons will be all of these ones. See, there's a whole lot more inner electrons, and those are all negative, and so they are all pushing on the electrons on the outside. They're all trying to repel the electrons that are on the outside. So as you go down the periodic table, you add energy levels. The outer electrons will experience more repulsive forces from the inner electrons. More energy levels means that there are more inner electrons exerting a repulsive force on the outer electrons. So we can say then ionization energy will decrease. I don't know if I said that in this one. For the shielding effect, I should have ended that sentence with ionization energy will decrease. All of these factors cause the ionization energy to decrease. So in general, guys, as you go down a periodic group, the ionization energy decreases. And then we're going to say due to, and then it's due to these 3 things: the distance of electron from the nucleus, the shielding effect of inner electrons, and then the repulsion effect of inner electrons. There we go. Thanks for watching.